What's up, guys? Welcome back to Null Void. Today we have a problem called remove nth node from the end of the list. This is a linked list problem which not only tests your coding skills but also if you are able to solve that problem efficiently, which is a very important thing in your coding interviews. So let's look into it.
Everybody knows that I'm breaking down. Everybody knows I ain't faking now. Everybody knows my heart's vacant now. Yeah, she hates me now. I made mistakes, but now I don't ever wanna be
So
alone.
let's look at the problem description. It says that given the head of the linked list, remove the nth node from the end of the list and return its head. So let's look at example 1 where we have this linked list and we want to remove the second node from the last because the value of n is 2. The second node from the last is the node with value 4. We remove it and we return the head of the list, and the modified list will look like this where 3 is directly pointing to 5 and 4 is removed. So the very simple way of solving this would be first traverse the entire list and get the length of the list. Let's say it was m and we want to calculate the nth node from the end. So what we will do is we will subtract n from m and then traverse this list to get the nth node from the end. But the problem with this solution is it is a two-pass solution where we are traversing the list twice, which we do not want to do. So what we could do better here, so to do it in single pass, what we could do is the other solution where we will use extra space. So in this solution, we'll create an array, and we that array will contain pointers to all the elements, all the nodes of this linked list. So when we have created the array, we can just take the nth node from the end in this array, and the to access any position in an array, we can access it in O of one time. So we can just get the nth node from the end in this array. It will have a pointer which is pointing to the nth node from the end of the linked list. So we can remove that node, and that would be our solution. But again, the problem is that we are using extra space here. So how could we do it without using extra space and in a single pass solution? So to do that, I'll take you to my board, to my drawing board, and let's see what we can do. Here we have this linked list, the same linked list as it was there in our example. We then the value of n is 2. We want to remove the second node from the end. So how we will do it is we will create two more pointers. So let's name them as front. I'll tell them what they mean. One is front, the other one is rear, and we'll traverse this list. So initially, the very first thing we will do is we will take this front pointer and traverse this list from value of I equals to 0 to n. What that means is, so let's say we have a pointer which is traveling from I equals to 0 to I less than n, and this front pointer will go for this. So after we are done with this, the front pointer first will go to the second node, and then it will go to this node. So so the so the new location of front pointer would be this, with the node with value 3, and our rear is still at the start of our linked list. Now next thing we would do is that we will traverse this linked list till the front pointer reaches the end of the list, and the rear pointer will also be traversing in the same manner, but it will not reach end of the list because the distance between the rear and front pointer is 2. So if we are able to traverse the front pointer when it reaches end, then the rear pointer would be pointing to the nth node from the end. So let's see how that works is. So when we start traversing and we want to traverse till front reaches to the end of the list. So in our very first traversal, F will come at this position and R will come at this position. So let me remove these things from here. Okay. So we see, did we reach the end of the linked list? No, we not. So we will remove F from here, and it will come at this position. And let's R will move at this position, and let's just remove it from here. Now we'll check, did we reach the end of the list? So 5 is the last element of the list, and the next of the this element would be null. So we have reached end of the list. Now we need to do one operation to remove the second node from the last. So what we can do is we can we can take the next pointer from this node where rear is pointing, where basically the node where value of the node is 3, and we can point it to the next pointer of the next node. So what I mean here is, I think this was a bit confusing. So what I'm saying is 3 is pointing to 4, 4 is pointing to 5. What I want is 3 should point to 5. So what I will do is I will see the node next to me. Where is it pointing? I'll ask the node next to me, where are you pointing? Give me your pointer, and I will make it as my next pointer. So what will happen is 3 will directly point this, and it will remove this connection. So now if you look at this list, now if we return the head of the list, then when it will traverse the list, it will go from 1 to 2, 2 to 3, 3 to directly 5, and 4 is no more there. To do some cleanup work, we might even remove the next pointer of 4 is, but for this problem, we may or may not do it. So that is how you will solve it. So let's go back to the code, and let's see how we will solve it. So let me paste the solution here, and as you can see, same problem. We are removing the we got head of the list. We want to remove the nth node from the end. So initially, as we did in our board, both head, rear, and front will point at the head of the list. So we will create two pointers, front and rear. They will point at the head of the list. And the very first step was move the front pointer n times. So we'll move the front pointer n times. So at next, the front will point to the basically n points from the start, and the distance between front and rear would be n. The next step would be to traverse the linked list till front reaches the last node. And how will we know that front has reached the last node? Is the next of the last node is always null. So front dot next till the front dot next that does not become null, we can traverse. We'll do this traversal, and in the end, the front will reach end of the list, and the rear will reach the n minus sorry n plus one th node from the end, because we want to delete the nth node, so we have to reach the n plus one th node from the end. So rear will reach the third node, and then we can just remove it. So what we did was we assigned the next pointer of the current rear to the next dot next of our rear. So I know this may sound confusing. So what basically we are doing is we are asking the so at initially the next pointer to the rear was node with value 4. So what we are doing is we are asking 4 to give me your next. So that's why we are doing rear dot next. So we will get 5 when we do this, and we are assigning it to the next of our rear. So rear dot next was initially pointing to 4, now it will point to 5, and this link between 3 and 4 will get removed, and hence we get our solution, and in the end we can return the head of the list. So I think that seems good. Sorry, I missed one condition earlier. So what happens if the value of n and the size of list is same? So let's say in this example, n was 5. We want to find the so we have a constraint in this problem that the value of n cannot exceed the length of the list. So the max value of n would be the size of the list. So in that case, we want to remove. So if we take example one, we want to remove the fifth element from the end, fifth node from the end. So we need to remove one. So what will happen if we try and do that? So then it will give null pointer exception when we go to our while loop where we are doing front dot next, because front would have reached the not just the end of the list, but it will go to the front dot next, basically null, because let's say if we traverse this here, that front needs to traverse 5 times. So in the first traverser where I is equals to 0, it will reach node 2. Then I equals to 1, it will reach node 3. I equals to 2, it will reach node 4. I equals to 3, it will reach node 5. and when I becomes 4, it will reach the null to the next of our end of the list, which is null. So if front becomes null, we cannot go traversing in our list again. So in that case, what we should do, we can just return head dot next. Why head dot next? Because in that case where the size of the list and the value of n is same, we want to remove the basically our very first element. So what we will do is we will return head dot next, and automatically our head will start from the second node in our list, and the first would get removed. So let's try to submit this solution. Hopefully it should work. Yep, that works. So that's how you solve remove nth node from the end of the list. So if you found this helpful, then please do leave a like, share it with your friends, subscribe to my YouTube channel, because I'll be making a lot of such videos. And if you have any doubt in this problem, or if you want me to solve any other lead code problem or any other coding problem, then you can comment that too, and I'll take a look. So that's all from my side for this time.
I don't ever wanna be alone. I don't really ever feel at home. On my own, in the zone. That's the only way I know. Feeling low, about to blow back up.